2025 question 10 starts off with an empirical rule question. So you know the empirical rule: 68, 95, 99.7 for your 1, 2 and 3 standard deviations. We're given the standard deviation of 60 here. So we're also given the mean of 400. So 400 in here, add 60 again, you get 520. Take away 60, take away 60. Nice easy intro. Work out normal distribution to find the proportion of students who scored above 420. Well, I'll do it if I do a little sketch. Where is my statistic? 400 in the middle. So it's above here, 420. Above 420 is going to be the tail. So the probability of greater than 420. So set up your z-score. We're testing 420 against 400 with a standard deviation of 60. Will be 20 over 60, which is 1 over 3. So we go to the z-score table. We find 1 over 3. 1 over 3 gives us a number of 0.6293. So the tail will be 1 minus 0.6293, which is 37.3707. 0.3707. Go back to the question, 2 decimal places, 0.37 for part 2. A random sample of students is taken from each country that takes part in the maths test, and the table below shows the mean score and standard deviation for 3 countries, X, Y, and Z. So by using the table, construct a 95% confidence interval for the population mean score of country S. So we have a mean of 387. Standard deviation is 66.2. We have a sample size here, 2161. So population mean, we need to multiply 1.96 by sigma over root n to get the margin of error. So 1.96 by 66.2 over the square root of 2161 is going to give 2.8. Just double check that, 2.8. 2.7911, so 2.8, 1 decimal. So the confidence interval will be, well, 387 is what we found. And the values are going to have to be between, if we add 2.8, 389.9, and if we take away 3, we get 384, so 384.2 for the confidence interval for X. For Y, researchers carried out a hypothesis test at the 5% level of significance to see if the population mean score was different to 400, the worldwide mean. The null hypothesis, they're giving you everything here. H0 is equal to 400 given. The alternative hypothesis, H1, is not equal to 400. Use the values in table. From the table, work out the test statistic, the z-score for the sample mean for Y. Give your answer to 2 decimal places. So Y we're testing 403 against 400, and we're dividing by, what have we got? Sigma over root n. We have sigma over root n, so it's, let me just check the number, 70.6 divided by 2724, the square root of 2724. That's giving me 2.2177. Might round this to 2.2. And if we get the z-score of 2.2, I get a number of 0.9868. So if we sketch this, we're testing 403. We've gotten the tail to be very small. 1 minus 0.9868 is just 1.32% in that tail. So there will be 1.32% in the other tail, which leads to the next part of the question. So sometimes they mention the radius of the confidence interval. The radius of this confidence interval is 100% minus 2.64% if we do it in percentage terms. So the radius is going to be 97.36%, which pushes it outside the 95% confidence interval. So we're going to have to reject this H0 that 400 is not the average for y. 400 is, the average is going to be different. So let's just see how they phrase that. They tell us to work out the p-value, which we've done. The p-value is 2.64%. And the conclusion, what I've been talking about, as the radius is greater than 95, radius greater than 95%, reject H0. Evidence to suggest the average is not 400 in Y. In country Z, we're told 50% of the students have a pet in their home and 50 do not. Okay, what's this about pets? Describe how the sample of 2520 students from Z could be taken as a stratified sample. Well, stratified sample, we split up the population into subgroups. So that's what they've done here. They split the population into subgroups, and we're told 50%. So the subgroups will be half of 2520, which will be 1260. So in each sample, 1260 is the stratified sample size for this. And the two subgroups here are having a pet. I don't know what type of information they're looking for here. Having a pet, not having a pet. And why would this not be useful in the context of the question? Well, it has no relation to maths course. Having a pet or not having a pet. So I think that's what they're looking for here in this second last part. In the last part, the student is picked at random. The expected value for the question will depend on the values of P and R. Find the largest value that the expected value of the mark could be. Okay, we set up an expected value table with 4 sectors. I'll just make them all the same size just for simplicity. This is 0 marks, this is 1 mark, this is 2 marks, and this is 3 marks. There's 0.19 getting 0. P are getting 1. 2 or are getting 2, and 3 is just for or. So I think if we focus on P here, we're asked for the largest value of the expected mark. Well, P could be equal to 0.81, or P could be equal to 0. The max and min is, I think this is the quickest way to do it. So if P is equal to 0.81, let's change this to 0.81. So we're going to have, this will be 0 in here, this will be 0 in here, so we're going to end up with the expected value just being 0.81 times P. And if P is equal to 0, then we're going to have 3 or will be equal to the 0.81. So or will be 0.27, and 2 or will be 0.54. So we set up that expected value. I think this is definitely going to be bigger. We have 0.19 by 0. We have 0 by 1. 2 or we're going to have 0.54 by the 2 marks. And we're going to have 0.27 by 3 marks. So the expected value of this one is 0 by 0.19 plus 1 by 0. So they don't count. So we're going to get 2 by 0.54. And 3 by 0.27. So we're going to get 1.08 and 0.81. So I think the max that we can get out here is 1.89 for the expected value. I think that's all they ask here in that last part of question 10.